This is a trigonometry review of the law of sines, taken for the Math 1060 Midterm 3 review, Dugopolsky Trigonometry Edition 3. This is section 5.1. Solve the triangle with the given parts. So the first thing we see is we're given two angles. And so the third angle is always easy to find. Let's start out with the fact that alpha plus beta plus gamma equals 180 degrees. Always. The three angles add up to 180. So we can get gamma by getting 180 degrees and subtracting our other two, the 26 degrees and the 51 degrees. This gives us, for an answer for gamma, gamma equals 103 degrees. Okay, we have found one piece. Now, instructions say solve the triangle, so we need to find all six. We have two angles and a side. We now have a third angle. What's missing is A and B. So, for example, oh, and by the way, because this is not a right triangle, gamma is not 90 degrees, we cannot use Pythagorean theorem. A squared plus B squared does not equal C squared in this problem, only for right triangles. But we use the law of sines. Let's go after B. So, in order to use the law of sines, you need to have an opposite pair. What I mean by that is, let me write this in, 103 degrees, we have C and gamma. That's an opposite pair. A and alpha, we don't have that as an opposite pair because we don't know A. B and beta, these are the opposite pairs. So C and gamma, B and beta, A and alpha. These are the opposite pairs, and we now have an opposite pair. Opposite pairs give you the law of sines as a tool. I want to solve for A, so I'm going to put A on top. A over sine of its opposite, alpha, equals, then use the opposite pair we have, C over sine gamma. We can solve for A, and we will get A equals C sine alpha over sine gamma. We then plug in our information, C being 26, alpha being 26 degrees, that's interesting, and gamma being 103 degrees. Now we plug this into our calculator, and we get, let's make a little room, A equals 11.697. I'm going to go to 11.7 rounded. One decimal place more than the information was given, but I'm not going to use 11.7 unless I need to, and I don't think I will. So that's how you find A. Now we find B in the same basic approach. B over sine beta equals, and I'm going to go back to C and sine gamma because that's the opposite pair that I am sure about. This 11.7 is an approximation, but the 103 degrees for gamma is an exact answer. So we know C and gamma, so we'll use that so we don't have approximation errors. B will equal C sine beta over sine gamma. We then plug in our information for 26 for C. Beta is 51 degrees and sine 103 degrees, and we get 20.737, so we will round that to just 20.7. B equals 20.7. We have found A, we have found B, and we have found gamma, and these three pieces of information were the three pieces missing. That is how we finished solving this triangle. Solve the triangle with the given information. Alpha, B, gamma. Right now we do not have an opposite pair. For alpha we need A. For B we need beta. For gamma we need C. However, since they give us two angles, we can find the third angle very easily, the same way we did the previous problem. Beta is going to be 180 degrees minus alpha minus gamma. In this case, 180 degrees minus 37.8 degrees minus 92.2 degrees, and that gives us beta equals exactly 50 degrees. That's nice. Now we have an opposite pair. We have beta and we have B. So now we can go after what's missing, A is missing, let's go after A. C will be next. So A over sine of its opposite alpha equals, and we're going to use the pair we have, B over sine beta, the opposite pair. This we can solve for A and get A, sorry, I'm weird looking A, let's try that again. A equals B sine alpha over sine beta. Plug our information in. B is 16.4. Sine alpha is 37.8 degrees divided by sine beta, which is 50 degrees. Plugging this into a calculator, make sure you're in degree mode, and this gives us A equals 13.121, rounded 13.1. We have beta, we have A, we have B, we need C next. So C over sine gamma would equal, and I'm going to go back to the opposite pair that we're sure about. I do not want to use this 13.1 because it's not 13.1, it's 13.1215307, etc. And I don't want to just use that. But 50 is exact. And B they gave to us, so we assume that's exact. So we use the information that we're the most sure about. This gives us an equation. We solve for C. This will be B sine gamma over sine beta. Now what I'm doing to solve for C, I'm just multiplying this sine gamma up. Everything else is staying the same. We then plug in the information, 16.4. I can do much better now. Let's try that again. 16.4 sine gamma, 92.2 degrees, divided by sine beta, 50 degrees. Now plugging this into your calculator gives you C equals 21.4 rounded. This gives us the three missing pieces of information, and we have solved this triangle. You can see from this technique that you do not have to graph this triangle, although if you do, it is very nice if they give you, in this case and they did, the fact that they gave us the largest angle, bigger than 90 degrees. We know this is obtuse, and that makes it a little bit easier to graph. Okay, moving on. Determine the number of triangles with the given parts. Now the number of triangles are either 0, 1, or 2. We have to determine of those which one this is. And if you know what to look for example, only one angle can be more than 90 degrees in any triangle. You cannot have more than one obtuse angle. Well, this is beta. The side opposite of the obtuse angle will be the longest side, so B should be the longest. But C is longer than B, which suggests that C's opposite angle, gamma, should be the biggest, and there's no way it can be bigger than 108. There's no triangle that's possible for this. On the other hand, we can just go with our law of sines. Notice we have an opposite pair, beta and B. So we can find the piece missing, the opposite of this, gamma. I'm going to write sine gamma on top, so it's easier to solve. I'm going to try to write sine gamma on top. Sine gamma divided by C equals sine beta divided by B. Solving for sine gamma, we would get C sine beta over B. We plug this information in, we get 54 sine 108 degrees divided by 44, and our calculator gives us 1.167-ish. Now, sine cannot be larger than 1. But if you still didn't notice, you go to trying to find arcsine, and you get error with your calculator. No triangles. The question, determine the number of triangles, I guess the answer would be 0. Okay, that's how you do this problem. Determine the number of triangles possible for number 4. B equals 24, C equals 28, beta equals 45. So what we would do, first off, notice we have an opposite pair, beta and B. So we go after the missing piece, and that would be gamma. So we would have sine gamma over C equals sine beta over B. Solving for sine gamma would give us C sine beta over B. And when we plug this into our calculator, we get 0.825. Now that's an approximation. There's more information there, and I'm going to use all of the information in my calculator to find gamma. Now, when we take, essentially, sine of an angle equals 0.825, where is sine positive? Well, all students take calculus. So sine is positive in the first and second quadrant. So there's an angle there and there. We need to find both of those angles because triangle angles can be up to 180 degrees. Not quite 180, but you can make a triangle with the degrees 179.9. It would be almost a straight line, but it would still be a triangle. So we need to get two answers. When we take arc sine, which might be written arc sine, that gives us the first quadrant angle. It gives us this one. Specifically, gamma equals 55.58 or 55.6 degrees. Now what I did is I did arc sine of the answer because I still had all of the information on the calculator. If you need to take your 0.825 ... and store that, do that. But have all the information so you get the full 55.6 degrees. Okay, the other one though is this angle. That angle, gamma 2, would be 180 degrees minus 55.6 degrees. And that gives us 124.4. Now that might not be possible, but we do have potentially two triangles here. Let me put a little gamma 1. What we need to do is we need to find the last remaining triangle and see if these work. So we have beta is 45 degrees right here. Each of these gammas might give us a full triangle. Let's find out if they work. So I'm going to find alpha 1. That's going to be 180 degrees minus the beta minus the gamma 1. This gives us 79.4 degrees. Well, that is definitely possible for a triangle. Let's see if alpha, oh, wrong color. Let's go black again. Let's see if alpha 2 works as well. 180 degrees minus beta minus gamma 2. That gives us 10.6 degrees. Both of these are possible angles. Sometimes when you do this, this answer is negative. In other words, beta and gamma, I'll get there. Yeah, beta and gamma are too big to leave anything left for alpha. In this case, they are not too big. We have two solutions. There are other ways you can work with the height of the triangle to see if it's possible and certain inequalities. What I like about this technique is when you use the law of sines to find an angle, which is what was missing. We have an opposite pair, beta and B, and so gamma and C. We can find gamma. When you find an angle with the law of sines, you always have two potential answers. Always. Try them. Get them both. Get the quadrant 1 angle from your calculator, 180 minus your calculator, get the quadrant 2 angle, and then see if they actually both create triangles. If one of your third angles is negative or 0, then that second possibility would be out and you'd be down to one answer. This gives you a nice technique that's pretty obvious. You don't have to worry about all the height inequalities. Sine equals a number, has two answers. Actually, it has an infinite number of answers, but it has two possible answers that'll work in a triangle. So go after both and see if they both work for the third angle. Great. How many possible triangles for this set of information? A, B, alpha. Notice we have an opposite pair, A and alpha. So we'll use the law of sines. And we have B, so we can find beta. Anytime you use the law of sines to find an angle, you have potentially two answers. So let's set this up and see how far we get. We can solve for sine beta. Sine beta is B sine alpha divided by A. When we plug our information into our calculator, we get sine beta equals 0.568333199. A lot of information. Now there are two possible answers here. Beta can be here or it can be here. There's two possible answers for sine is positive because all students take calculus. Now there's actually an infinite number of solutions to sine beta equals 0.568. Infinite number. There's two solutions once time around the circle, and they both lie below 180 degrees, so they're both possible answers for a triangle's angle. Now using arcsine of our answer, and I'm not just using arcsine of 0.568, I'm using arcsine of the full information, we get our first beta. Beta 1 would equal 34.6 degrees. That's this one. But we also could have the second quadrant angle, which would be 180 degrees minus our calculator's answer. And that gives us 145.4 degrees. Each of these might work. We have now alpha and some betas. So we can find the gammas. Let's find gamma 1. Gamma 1 would be 180 degrees minus alpha minus beta 1. That would give us, on our calculator, 102.4 degrees. Well, that's definitely something that's possible. Now for our second one, what about gamma 2? That would be 180 degrees minus the alpha that was given, minus the beta 2, which is our second quadrant potential answer. And that gives us a negative 8.4 degrees. Well, that's not possible. So our second quadrant angle was so big, 145 degrees, that when we combined it with the 43 degree alpha, there was nothing left over for our third triangle. So this part didn't end up working, leaving us only one possible answer. And that is with beta equals 34.6. These problems are not asking us to solve the triangles. We have beta, we could find B and what's missing. We could find C and we've already have gamma. So we're very close. All we need to find is C to finish solving the triangle. But they're just asking for us how many answers do we get. The trouble with these triangles is when you use the law of sines to find an angle. When you use the law of sines to find an angle, always consider the two possible answers and then see if they both work. Our previous problem, they both gave us a positive answer. This one of them gave us a negative, so that didn't work. We crossed it out and we only have one answer. Hope this helps. Solve the triangle. If there is more than one triangle with the given parts, give both solutions. Okay, let's check. We have B and beta. We have an opposite pair. The other piece is A, so its opposite missing piece is alpha. Anytime We have an opposite pair. We'll use law of sines. Anytime you use law of sines to find an angle, there's potentially two triangles, and we'll try to see if we can get both triangle answers. One of them might not work. So let's start off going for alpha. Sine equals, over A equals sine beta over B. This gives us sine alpha equals A sine beta over B. So sine alpha would equal, when we plug this into our calculator, 0.4999. So just about 0.5. But this goes on forever. Taking arc sine of this answer gives us 29.99 degrees, which we'll round to 30.0 degrees. All right, now that's alpha 1. Because we have a potential two solutions, there's an infinite number of solutions to sine alpha equals a number. Two of those solutions, specifically there and there, are possible answers for a triangle. All students take calculus. There are two answers, first quadrant, second quadrant, where sine equals a positive number. So we also need to try out alpha 2. Alpha 2 would just be the second quadrant, would be 180 degrees minus alpha 1. That's specifically alpha 2 equals 150.0 degrees. Now these are our two potential answers. I don't know if they're both going to work. So we try them out. Let's see. Let's make this two problems here. So for alpha 1 equals 30 degrees. Well, we can go after gamma now. Gamma equals 180 degrees minus alpha 1 minus beta. These are the information we have, and that gives us, let me go gamma 1. Gamma 1 equals 122.5 degrees. That's fine. That's a great triangle. So now we go after C. Finish this one up. C over sine gamma equals, and our complete pair to begin with is B over sine beta. So C equals B sine gamma over sine beta, and when we plug that into our calculator, we get 27.85, which we'll round to 27.9. Now, what we have here is alpha 1, gamma 1, and C. I should write that C1. C1. Great. Let's make sure we can see those. That's one solution. Solving these triangles is finding the three missing pieces. But we also have potentially an alpha 2. We don't know if this will work, but we got to try. So 150.0 degrees. Gamma 2 will be the same formula. 180 degrees minus alpha 2 minus beta. Almost the same formula. Gamma 2 equals 2.5 degrees. Now that is positive. That means that we actually have another circle here. Another triangle here, going full circle. So we have another triangle. Let's continue on. C2 would equal B sine gamma 2 over sine beta. That's the same work here. So I just skipped a little bit. And C2 equals 1.43. Great. We have also alpha 2, gamma 2, C2. We have two full solutions. This question said if there is more than one triangle, which we have more than one triangle, give both solutions. We have given both solutions. We have them labeled alpha, beta, gamma 1, alpha, gamma, C2. So they're all labeled separately. We can tell these are two different solutions. When you use the law of sines, which you know you're going to do because you have an opposite pair, and you use it to find an angle, in this case alpha, you always go for two solutions, the first quadrant alpha and the second quadrant alpha. It's not until you find the third missing angle that you find out if that second solution is possible. If this angle is positive, it's possible, and finish the solution. The first one's always going to be a solution if you get an answer for the missing angle alpha. All right, let's move on. Solve the problem. A guy wire to a tower makes a 75-degree angle with level ground. So we have a tower and a guy wire with level ground, so that's a 90-degree angle. The guy wire makes a 75-degree angle at a point 40 feet farther from the tower than the wire, but on the same side as the base of the wire, so over here. The angle of elevation to the top of the pole is 33 degrees. And that is 40 feet further. Okay? Find the wire length. We want to find this length, x. Now, essentially, we have this triangle we're trying to find, where this is 40, this is 33. We're looking for, oh, I put it degrees for 40, sorry, let's erase that a little bit. There we go. We're looking for this. With that triangle, in order to find pieces in a triangle, you need 3 pieces. We only have 2 pieces, so somehow this other triangle with 75 degrees and let's see, how tall is the tower? Do we know? Nope. We've got to somehow get something out of this. Now, the solution to our problem is the fact that these right there are supplementary angles. They add up to 180 degrees. Well, 180 degrees minus 75 degrees is 105 degrees. That's the missing ingredient to our little triangle. We now have 3 pieces on our triangle. We can find our third angle because 180 degrees minus 33 degrees minus 105 degrees will be our third angle. I don't know what to call it. Let's call it alpha. So that will be 42 degrees. Okay. So what we have now is we have an opposite pair. Let's go in and label these. A, alpha. Let's call this B, and that'll be beta, and C and gamma. Just because we're so used to doing this, perhaps. Maybe you're not, but it's a good way to go. So we have, let's write this down in like our last kind of problem. We have A equals 40 degrees. Degrees again. I don't know why I keep doing that. Alpha equals degrees, though. Alpha equals 42 degrees. And beta equals 33 degrees. And find B. Now, if only they'd given us this problem, we would be happy, because that's not very hard to do. In fact, we have an opposite pair, and the piece we're needing is opposite of the 33 degrees. So that's awesome. All we have to do is set up a sign. A law of sines, B over sine beta equals A over sine alpha. Let's get a little room here. So B equals A sine beta over sine alpha. And when we plug this into our calculator, it would be 40 sine 33 degrees divided by sine 42 degrees. We get 32.55, and the instruction said round to the nearest foot, so we will go to 33 feet. All right, let's recap this problem. So to begin with, the picture was very important. We had a tower. We were standing so that there was 75 feet from the tower, or 75 degrees angle with the level ground, and then a point 40 feet further away, 33 degrees to the top. And they wanted to know the length of this guy wire. Now, the guy wire, we didn't know much about this triangle. We only know one angle. I guess we know two angles, but we don't know any of these sides. The only side we had was on this stranger looking triangle. And we had an angle there. We only had two pieces of information though. We had an angle and a side, but because this is 75 degrees and that's supplementary, we were able to get this third angle, sorry, the second angle, 105. Then with those two angles we got our third angle of 42. That's the amount of work it took before we finally had an opposite pair, so we could use the law of sines. Now if they needed C, we could have found that because we have the opposite of that. They wanted this length, we called it B, and we had the opposite, so we just went to find B. Once we had that information, this was a pretty straightforward problem. Excellent. A sailboat leaves port on a bearing of south 72 degrees west. After sailing for 2 hours at 12 knots, the boat turns 90 degrees towards the south. After sailing for 3 hours at 9 knots on this course, what is the bearing to the ship from port? Anytime I have a problem like this with the bearings, I usually do a quick sketch to get an idea of how things are laid out, and then I have a little more careful, larger picture so I can fill in some information. Alright, so here we are. We're at port. South 72 degrees west is like there. We go for a while. 2 hours at 12 knots. The boat turns 90 degrees towards the south. Okay, and then 3 hours at 9 knots. We eventually get somewhere, and then they want to know the bearing to the ship from port. To the ship from port. So it's going to be that kind of answer. South so many degrees west. I think it might be a little further, might be east, but at least this gives us an idea of our picture. Now, 2 hours at 12 knots, that would be distance 24. 2 times 12. 3 hours at 9 knots. 3 times 9 is 27. So this picture actually looks pretty close. Now we've got our right angle and we need to figure out the south 72 degrees west. So this is when it's nice to expand our picture. Now that we have a basic picture, 90-degree angle, 24 and 27. South 72 degrees west. That's this full angle, 72 degrees. That's not the angle in the triangle. This angle is what we're actually looking for, or at least it would be great if we had. We could find what we need. Okay. Now we have a situation here where we have parallel lines, these parallel lines, and we have a bisector. It's not a perpendicular bisector, but it is a bisector, and when that happens, we know information like this angle is the same as this angle. This full angle is the same as this angle. Well, now this one is perhaps useful here. I'm not quite sure yet how we're going to solve this problem, but we just continue on until we do. With this information, what we're needing is an opposite pair. Now because it's 90 degrees, we actually can use the Pythagorean theorem and find this side, and then we'd have an opposite. We don't have an opposite pair, we'd have that opposite pair, and using that we could find another piece. So I guess we could solve this problem without the law of sines for a while. Now this problem is special because it gave us 90 degrees. That means we have a right triangle, Pythagorean theorem. That's not as common as you might think. And we can also use tangent, for example, for this angle, or for this angle. Ooh, that's so good. Let's do this angle. Let's call that alpha. Tangent of alpha equals 27 over 24. This is just SOHCAHTOA. Because it's a 90-degree angle, we're getting lucky on this problem. You can solve this with the law of sines in other ways, but I think this is a lot easier than it should be. So with tangent alpha equals 27 over 24, using your calculator, we take arctangent of 27 over 24 in degree mode, and that gives us alpha equals 48.366, so 48.4 degrees. That's great. That means that we can find the solution to our problem pretty easily. So we need to know this angle right here. Let me put it in black. This is the angle that we're trying to find. That's the bearing to the ship from port. So here's port up here, and here's our ship. And we're so thankful they turned 90 degrees to allow us to use our simple tools. If we knew what this degree right here was, then we could say it's south so many degrees east, or west, sorry, so many degrees west. Now this whole thing is 72, and this is 48.4, so this little bit right in there is 72 minus 48.4 degrees, which gives us 23.6. 23.6 degrees. So we would be going south 23.6 degrees west. And we saw this as a right triangle because we were blessed by this guy turning 90 degrees towards the south. Oh, thank you. If not, this would have been a little more work, but this was a very nice problem. Okay.